Hello everyone, as you can see that I will teach you about set and subset. In our group have 2%. The video creator is made by Thiness and I'm the presenter Adlan Hanifi, also the video creator. So the objective is student will be able to define set, inclusive, element and object. Second, student will be able to identify the element of a given set. And lastly, student will be able to recognize when to describe a set and its element. Do you know that set have been applied in our daily life? As example, we go shopping in a mall. We all have noticed that there are separate portions for each kind of thing. For instance, clothing shop are on another floor, whereas the food court is at another part of floor. So, we will talk about what is a set, what is a subset, then what is a power set, and the operation on set. So, what is that? So, for the first part is, what is a set? Let's go. Definition of a set. A set is a well-defined collection of objects. The objects in a set are called elements or members of the sets. The phrase well-defined means that we can describe exactly what is and is not in the set. Repeated element is not important. Explanation about sets. Let set S be the months of the years. So S is January, February, March, April, May, June, July, August, September, October, November, and December. Curly braces are used to enclose the member of the set. For the empty set that has no element is denoted by this symbol or this symbol. Let's say D have 5, 4, 3, 2, 1 and E have 1, 2, 3, 4 and 5. So we use the element symbol to show that an element is a member of a set. Not element symbol is for not element of a set, and equal symbol for set that have the same element to the another set. So the first 3 is element D, since 3 is one of the number in the set of D. Second, 7 not element of E, since 7 is not list in the set of E. D equal to E, since set D and set C are equal. Another way to write set is using set builder notation. As the example, S equal to X, condition on element. The symbol is read such that S X such that X element to N and X is less than 10. This is read S is the set of elements such that the element are natural numbers and the element are less than 10. As the example, S 1, 2, 3, 4, 5, 6, 7, 8, 9. Two sets are said to be disjoint set if they have no element in common. Equivalently, two disjoint sets are set whose intersection is the empty set. Okay, the example is A have 1, 2, 3, B have 4, 5, 6, and C has 3, 4, 5. So the first A and B is a disjoint set because they know a duplicate number in set A and set B. For the second, A and C is a not disjoint because set A and set C have a duplicate number. Finite sets are defined as set with a finite number of elements that can be counted. For the as example, A, X such that 1 less than X less than 10 means the X is less than 10 more than 1. Infinite sets can be understood as sets that are not finite, that the elements of the set are endless. For the example, B, X, such that X more than 1. So the X is countless. Let's go to the other section. What is a subset? Keep going, you are doing great. Definition of a subset. A set A is a subset of A set B if all elements in set A are also in set B. X, January, February, March, April, May, June. Y, January, March, June. Z, January, March, July, November. So Y is subset X, since Y is a subset of X because element in Y is least on the element of X. Z not element of X because sum of element in set Z are not same with element in the set X. So for the next section is what is power set? Just a little bit more. Power set. Power set is defined as the set or group of all subset for any given set, including empty set. For example, let's set A 1, 2 and 3. Therefore, the total number of elements in the set A is 3. Let us find the power set of set A. For example, set A have 1, 2 and 3. So the subset of set A have a empty. So let's go to the last part, the operation on set. Never give up. The operation on set have 4: union, intersection, complement, symmetric difference. First, union. The union of two sets contains all the elements contained in either set or both sets. The union is notated A union B. For intersection, the intersection of two sets contain only the elements that are in both sets. The intersection is notated A intersection B. Complement. The complement of a set A contains everything that is not in the set A. The complement is noted A or AC or sometimes A. Symmetric difference. The symmetric difference of two sets is the set of elements which are in either of the set, but not in their intersection. For example, A is red, green and blue. For B, red, yellow and orange. For C, red, orange, yellow, green, blue and purple. So first, A. Find A union B. The union contains all the elements in either set. A union B. Red, green, blue, yellow, orange. We notice that the red have a duplicate, but we list the red only once. For B, find A intersection of B. The intersection contains all the elements in both sets. A intersection B is red. Because red have a duplicate, so we list only red. For C, find complement A and C. Here we are looking for all the elements that are not in set A and or are also in C. So the answer is orange, yellow, purple. Because red, green, blue have a duplicate, and we only list are not in set A and are also in C. For D, find A symmetric difference B. Here we are looking for the element that are not duplicate in set A and also in B. So the answer is green, blue, yellow, orange. as we know that red is a duplicate element.